So hi friends again. Today we are going to see topic 1.3 from ISTQB Foundation Syllabus of chapter 1, and this topic is about 7 testing principles. So let's start. So let's see how the whole thing is arranged. So in ISTQB Foundation level we have these 6 topics, and today we are talking about this third topic, which is 7 testing principles. So in this video you are going to cover 7 testing principles. So now the question is, what are the 7 testing principles for the testing? So in ISTQB Foundation Syllabus, there are 7 principles which are described, and they are: first principle is testing shows presence of defects. Second principle, exhaustive testing is not possible. Third principle, early testing saves money and time. Fourth principle, defects cluster together. Fifth, beware of pesticide paradox. Sixth, testing is context dependent. And seventh, absence of errors is fallacy. So we will see every and each principle one by one with some of practical examples. Coming on the very first principle, which says testing shows presence of defects. What exactly it means? It means testing cannot show that the software is error-free. Testing reduces the probability of undiscovered defects remaining in the software. So in simple words, this means testing fills the confidence into the mind of the team, into the mind of organization, that end customer are very less likely to find the defects. But it doesn't mean that the software is error-free. Let's understand this concept with the help of an example. So I'm having a software which is having a login screen, and as a tester I am responsible to test this login screen. Even if I have covered various combinations and permutations of username and password, and I have tested all the functional aspects, I cannot say that this piece of software is error-free, because there might be some non-functional aspects of error. For example, usability. End user doesn't like the screen, or end user doesn't want the color coding scheme. So this can be an error or a bug from end user perspective. Another thing is security. Might be a chance that once end user is encountering with this application, he found some security issue on the login screen. So this may be another bug. Another aspect is performance, which is also very important. So assume an example where on a particular point of a time, thousands of users are going to log in into the screen, and eventually the login screen fails. So in a nutshell, what I want to say is, what this principle says is, testing doesn't guarantee that the software is error-free, and it's not a right way to say that the software is error-free even if you are done with lot of testing, because there always a chance of some hidden defects in the software. Second principle is exhaustive testing is not possible. Let's understand this principle with the help of one example. Suppose you are having a login screen, and in this login screen the specification says password can be of 3 characters. So they can be any 3 characters like ABC, BDE, TRX, or whatever. Now as a tester you have to write the test cases, or you have to do the testing for the password. So my question is, how many possible password combinations you can test? Possibly 10, or maybe 20, or maybe 30. But can you assume with English characters, if English characters are allowed for the password, we can have 26 into 26 into 26 combination, because one character can be replaced by 26 places, another character can be out of 26 English characters, and that's the same for third one. So the question is, can you do 26 into 26 into 26 combination testing for the password? The simple answer is no. And that's the meaning of exhaustive testing. We cannot test the software for all possible combination and permutations of the given input fields or of the given scenarios. And that's why we say exhaustive testing is not possible. Third principle, early testing saves time and money. Let's understand this with the help of another example. So for example, you have some specifications, and these specifications are given to you on day one. And these specifications are for adding a new registration form in the software. And this registration form comprises of first name, last name, email, password, confirm password fields, and there are some certifications that how many characters each field is having. Suppose on day 15, this form is developed by the developers, completely developed by the developers and ready for the testing. Now the question is, what you are doing between day 1 and day 15? What as a tester, what exactly you are doing? Are you sitting idle? Is this a good practice? No, it's not a good practice, because we are utilizing these 14 days of time in lot of static testing, which means reviewing the test cases, preparation of the test cases, and going through the requirements again and again to see all the requirements are feasible. And that is the concept of early testing. We don't have to sit till the piece of software is completely made by the developers. In the meantime, we have to try to make some static testing, which is also known as early testing. And this early testing in terms of analyzing the requirements, preparation of test cases, and this early testing saves a lot of money and time. This concept we will also see in the chapter static testing, where we will see how the time and the money is being saved from early testing. But now, as a concept of testing, I think it's very clear to you that early testing is always desirable and it saves a lot of time and money. Let's come to another principle which says defect cluster together. This principle is based on Pareto principle, and the Pareto principle also says approximately 80% of the problems are found in 20% of modules. So let's understand it with another example. So we have a software under test, and for example, the software under test is categorized into 5 different modules: M1, M2, M3, M4, M5. And we are getting a lot of defects within these modules. And at the end of the software development life cycle, we are categorizing that how many defects we are getting in which module. So for example, for module 1 we are getting 8 defects, for module 2 we got 2 defects, module 3 2 defects, module 4 2 defects, module 5 1 defect. So Pareto principle says that in most of the cases, majority of the bugs are coming from a single module. So in this case, M1 is the module from where the majority of the defects are coming, and that's why more concentration is given to such module which is responsible for defects cluster. And more or less, it's not scientifically proved, or it's not very which we can hard code like 80% of the problems are found in 20 defects. So it can be 70-30 or maybe 60-40, but the essence is that majority of the problems are coming from such a cluster, and we have to concentrate on the cluster in order to fulfill the testing needs. Another principle is beware of pesticide paradox. What exactly it means? It means running the same sets of tests continuously will not continue to find the new defects. Let's understand it again with the help of an example. You are having a mobile app in which you are having a registration field or registration form. In this registration form, you have to fill username, email, confirm email, and password fields. And suppose this app is having different versions, version 1, version 2, version 3, and version 4. Now, the question is, one approach can be you are testing this user form with the help of email, and you are using abd@gmail.com for both the versions of the application. So for a version 1, you have used abd@gmail.com while registration. When the version 2, you are using abd@gmail.com while registration. In the version 3, version 4, version 5 of this app, you are using every time, and we are supposing that these versions are coming after every month. So every month you are testing it and using the same email ID. This is the one approach. On the other hand, you have a second approach where you are using different emails in different versions. So the version which is available for the customers in month of January, you have used abd@gmail.com. For the version 2, which is available for the customer in the month of February, or which is released in the month of February, you have used cde@hotmail.com. So you have changed the domain name, and you have also tweaked the first half of the email address. Now the question is, which approach is more sensible? Obviously, the second approach is more sensible because here we are continuously changing our data sets for the test cases. We are modifying the test cases. And obviously there are very less chances, for the first approach to find the defects. So it's always advisable when we are going through iterations, when we are going to different cycles of software and we have to run some particular test, we have to use different kind of inputs or we have to modify our test case on a continuously basis. And this is the right approach. If we are not continuously updating the test cases or we are not changing the test cases, there are very less chances that we can find the new defects. Another principle is testing is context dependent. This is very simple. So for example, you have three different kind of application. The one application is a banking application. The another application is a mobile application, which is kind of a e-commerce application on mobile. And the third one is embedded system application. For all these applications, the challenges are different. For example, in a banking application, we are very much concerned about the data security. For e-commerce application, which is on a mobile, we are very much secure. We are very much concerned about how the display will be on different mobiles and how the application will work on, different sets of mobile, how it will work on iOS, how it will work on Android or the Microsoft phones. So this can be the real challenge. For embedded system, again, the challenge is a bit different then because here we have to more concentrate on performance. Here we have to more concentrate on hardware and the software interaction, and the hardware can be of different types. So for different applications, the challenges are different, and that's why the approach for the testing is also dependent on the kind of application which is under test. So we are defining the test strategies, we are defining the test plans, we are coming up with all our experience based on the domain knowledge, and then we are defining how the testing needs to be done. And that's the meaning of testing is context dependent. And the last principle is absence of error is fallacy. So it's a combination of two principles which we have already read. The first principle is the software cannot be error-free, and the second principle is exhaustive testing is not possible. So it is the combination of both two principles. And what it says any fallacy, like a mistakenly belief, to expect that just finding and fixing large number of defects will ensure the success of system. So it is fallacy. So it's saying like it's a mistake if we say that we have found a large number of defects and this leads to the success of the system. Let's understand it with help of another example. So I have an application, I have the version 1 of the application. For this version 1, I have found 150 defects. Testing team has found 150 defects, and consequently 150 defects are fixed by the developers. There is no active bugs and there is no improvement. Now consider two statements. The statement 1, software is ready to ship in production, and the statement 2, software is error free. Obviously, the second statement is not the right statement. Even if we have found a large number of bugs and we have fixed the large number of bugs, we can't say that software is error free. But yes, we can say software is ready to ship into the production. So even we have already found a lot of bugs and we have fixed a lot of bugs. We can't say software is error free, and it's a mistakenly belief by the companies if they assume that they will not find any bug once the software is in production, because it's very hard to say this thing that software is error free. As I already explained, there are a lot of non-functional aspects and there are some other aspects which completely makes a software is an error free, and there always a chance that the software can encounter a bug. The only thing which testing assure is it fills a confidence into the mind of the team that whatever we are delivering is less error prone, is less bug prone, or the critical bugs should not be there. So that's all about the principles of software testing, and for more details you can visit our website where you can find the way how to get one-to-one guidance. You can find some free sample papers, more videos, and also free study material. Thank you very much for listening and stay tuned. Bye.